Question number 17. We have a determinant y plus z x x y z plus x y z z x plus y equals one of these four determinants. So we must simplify the original one. First step, by subtracting r1 minus r3. So we will subtract r3 from r1, the third row from the first row. So we have another determinant in this form: y plus z minus z equals y x minus z, x minus x plus y. So we have negative y, and we write r2 and r3 without any change: y z plus x, y z z x plus y. Then by r1 plus r2. So we have r1 plus r2, y plus y, 2y, x minus z plus z plus x equals 2x, as negative x plus z, negative z plus z equals 0, and the negative y plus y equals 0. And we write the second and the third rows: y z plus x, y, here is z, z x plus y. And we can take the number 2 as a common factor from the first row. So we have y, x, and 0. Here we have y, z plus x, and y, z, z, x plus y. Okay, so by r2 minus r1, by r2 minus r1. So we keep r1, y, x, 0, and the change will be in r2 again by subtract r1 from r2. Okay, so y minus y equals 0, x minus z minus x, y minus y equals 0, z plus x minus x equals z, y minus 0 equals y, and the third row will be z, z, x plus y. So we want to simplify the third row by subtracting by r3 minus r2. We get a new determinant. Again, r3 minus r2, z minus 0. So we write first the first row without any change: y, x, and 0. And the second row: 0, z, and y. Now, z minus 0 equals z, z minus z equals 0, x plus y minus y equals x. So the final form, here we have y 0, z, x, z 0, 0, y, x. Of course, we must write the number 2. This number, we forget it. Here is 2, and here is 2. And this is this result in letter C. Here in letter C, we have the same determinant. Okay, yx0, yx0, 0 zy, 0 zy, z0x, all multiplied by 2. So this is right answer. Next question. Question number 18. If the system of equation 2x minus y minus 3z equals 2, x plus y plus z equals 1, 3, x minus 5y plus 2z equals 13 has a unique solution, then x plus y plus z equals. Directly we can solve this equation using calculator. Okay, here we have mode equation, and here we have into, and we write the coefficients. The coefficients of the first equation 2 equals -1, equals -3, equals 2. Then 1, 2, 1, 1. Equal x equals 2. We write it. Y equals -1, and z equals 1. So the required is x plus y plus z, which equal 2, plus -1 plus 1, which equal 2. And the solution will be in letter B. Next question, question 19. Here we have r equals 1 minus root 3i, z2 equals 1 plus I, and the I square equals -1. The number z equals z1 over z2 in the exponential form. Of course, we can use calculator to find z, which equals z1 over z2. Equals, here we write in the numerator 1 minus root 3i. The denominator will be 1 plus I. So we go to calculator. We must use it to save time. Complex at number 2, and we write this fraction. 1 minus root 3 I over 1 plus I equals, this is the number. Okay, we must determine the theta. We wanted to know theta and r. Theta and r. What is the value of theta? The amplitude. And what is the value of the modulus? Using calculator. So we go to shift and complex here at complex at number 2. Okay, here we wanted to find r and theta. R and theta. So we must press 3. Okay, equals, here we have r equals root 2 and theta equals negative 105. Negative 105 degrees. and r equals root 2. We will change theta from degrees measure to radian measure. So theta equals negative 105 over 180 pi. Back to calculator again. Fraction negative 105 over 180 equals negative 7 over 12 equals negative 7 over 12 pi. Okay, here is the modulus, here is the principal amplitude, and this result. So z in exponential form equals root 2 e power the angle theta negative 7 over 12 pi I. Here is at D. The result at D. Question number 20. The number 2 root 2 1 plus I in trigonometric form. Again, we will use calculator, okay, to determine the modulus and the amplitude. So we write, here is, we're still in complex, right? So 2 root 2 multiply 1 plus I equals, this is the number in the simplest form, and we press shift complex at number 2. We want to determine r and theta, so we press 3 equals the radius r, the modulus r equals 4, and theta equals, again back to calculator, equals 45 degrees. So we will choose C or B, and we have pi over 4 in C, and this is the solution. Okay, so the answer is at C. Question number 21. If A and B are two unit vectors, so first we have to remember that the norm of A equals norm of B equals 1, because it is a unit vector. Measure of angle theta between them, measure of the angle between them is theta. Then 2 norm of A cross B, A dot B. Here we have vector product, and here we have dot product. So the result equals 2. We know that from the rule A cross B equals norm of A, norm of vector A, norm of vector B, sine theta. You will not write the unit vector C here, because we write a norm of A cross B. Okay, this is the first part. Second part, A dot B. A dot B equals norm of A, norm of B, cosine theta. Theta, the angle included between them. And we back to simplify. 2 multiply the norm of A equals the norm of BH equal 1. So this part equals sine theta, as 1 multiply 1 multiply sine theta equals sine theta. And here also second bracket will be cosine theta. Now we have 2 sine theta cosine theta, which equal sine 2 theta. It's trigonometry. And the result will be D. Next question. Question number 22. Here we have NCR equals NPRF. Okay, NCR equals NPR. But NCR equals N permutation R over factorial R. And right hand side will be N PR over 1. So simplifying, dividing both sides by NPR, we will get factorial R equals 1. So when factorial R equals 1, it means R equals 0 or 1. So the two sides are equal. NCR equals NPR if R equals 0 or 1. And we have this answer in letter D. Next question. All the following points lying on the same side of the plane R dot 3i minus 5j plus 4k equals 5, except one of this. Solution. We know that R is the point X, Y, and Z. It is a general point on the plane. Dot 3i minus 5j plus 4k equals 5. This is the equation of the original plane. Now we will take the left hand side, substituting x, y, and z by the first point. So we have 1, 2, and 1 dot 3, negative 5, and 4. Okay, 1, 2, 1, 3, negative 5, and 4, and the result will be 1 multiply 3 equals 3, minus 10 plus 4, which equal 3 plus 4, it's 7, equals negative 3. Negative 3 is less than 5. Okay, 3 minus 10 plus 4. 3 plus 4 equals 7, minus 10 equals negative 3. And the same, we will repeat this step with the rest of 3 points. So we have 0, 1, 0, negative 1, and 2, dot 3, negative 5, and 4. And here is the result equals 13. It is greater than 5. And with respect to the point at C, we have 2, negative 3, and 1, dot 3, negative 5, and 4. The result equals 25. It is greater than 5. The point at D, here, we have 1, 2, and 4. Here is the point 1, 2, and 4, dot 3, and the negative 5, and 4, which equal 9. and 9 is greater than 5. So these 3 points here all on the same side except the first point. So the answer will be at the letter A. Next question, 24. The number of the integer terms in the expansion of root 3 plus 1 over root 3 power 7 is. Here we ask the question about the number of integer terms. And you have to remember the integers, the set of integers is numbers like -3, -2, -1, and 0, 1, 2, 3, and so on. This is the set of integers. And you have to remember that we have another set which contains numbers like root 3, root 5, pi. You have to remember this, and so on. This set is Q dash. It is a rational number. Of course, this irrational number doesn't belong to integers. Okay, back to the question. Here we have in the expansion of root 3 plus 1 over root 3 all power 7. First, we write a general term. We start from general term. TR plus 1 equals NCR. Second term, 1 over root 3 power R. Multiply first term, root 3 power N minus R. 7 minus R, as N equals 7. And I'll correct it here. 7. Okay. Now it is equal 7 CR. We simplify it. Root 3 minus R multiply root 3 power 7 minus R. Okay, here is multiply. So the general term will be in the form 7 CR root 3 power 7 minus 2R. Here R equals, it is started from 0. Here we have 8 terms. Substituting R equals 0, we will get the first term. Substituting R equals 1, we will get second term, and so on. So when you substitute R equals 0, okay, we have to concentrate at this part, because always we have a number here. 7C0 equals the number. 7C2 equals integer, always integer. Okay. Now root 3 power 7 minus 2 multiply 0. We have root 3 power 7 minus 2R. Put R equals 0. So root 3, the number will be root 3 power 7. And root 3 power 7 belongs to Q dash, not integer. Again, repeat it. Okay, put R equals 1. We will get root 3 power 5. And also it is belong to Q dash, not integer. So after you repeat it from 0 to 7, you can say for every R belongs to the set 0 to 7, 0 to 7, there is no integers. So the number of integers equals 0. And we choose letter A. Question number 25. Here we have if the modulus of Z1 equals modulus of Z2 and the amplitude of Z1 plus amplitude of Z2 equals 0, then Z1 equals Z2, conjugate of Z1 equals Z2, Z1 plus Z2 equals 0. The conjugate of Z1 equals the conjugate of Z2. Now we have absolute of Z1 equals the absolute of Z2 equals R. R is the modulus of each of the two complex numbers. And here we have amplitude of Z1 is theta 1 plus theta 2 equals 0. When theta 1 plus theta 2 equals 0, it means theta 2 equals negative theta 1. So Z1 equals R cosine theta 1 plus I sine theta 1, and Z2 equals R cosine negative, as theta 2 equals negative theta 1 plus I sine negative theta 1, because Z2 equals R cosine theta 2 plus I sine theta 2, and theta 2 equals negative theta 1. So Z2 equals R cosine negative theta 1 is cosine theta 1, because cosine is even function. So cosine negative theta equals cosine theta. Sine is odd function. So sine negative theta is negative sine theta. Negative I sine theta 1. So Z2 equals Z1 bar, the conjugate of Z1. Okay, here is the answer at letter B. Question number 26. Here we will use calculator to solve it to save time. Put omega equals negative half plus root 3 over 2i. And we go to calculator. We write omega. Instead of omega, I'll denote it by the symbol x. So first we write the fraction negative 1 over 2 plus root 3 over 2i. Where is I? Okay. And shift RCL, and I'll choose, okay, or x, okay. We know x, and the AC again. So instead of omega in this expression, we write x. So we write first bracket fraction x over 1 plus 2x all square. Okay, it is the first part, the first fraction square, plus another bracket fraction x square all over 1 plus 2x, okay, all square, and the result equals 1 over 3. So this expression equals 1 over 3. And we choose letter D. Okay. Next question, question number 27. The volume of the parallelepiped in which AB and AC and AD are 3 sides of course this is three adjacent sides in this parallelograph. Okay, and the parallel will be in this form like this. Here we have A, B. Here we have A, C, and AD. This is the three sides. I mean, three adjacent sides. AB, AC, AD. Okay. And the volume equals the triple product. To get the triple product, first we must calculate each of AB, AC, and AD. So AB as a vector equals B minus A. B minus A, which equal B, it is of coordinates 2, 1, and 3, minus A, 1, 1, and 1. So AB equals 2 minus 1, it is 1, 1 minus 1, and 0, and 2. It is AB, 1, 0, and 2. Again, we calculate AC. AC equals C minus A, 3, 2, 2, minus A, of coordinates 1, 1, and 1. And the result equals 2, 1, and 1. It is AC. What about AD? It is the third side. AD equals D minus A, which equal 3 minus 2, it is 3 minus 1, it's 2, 2, and 3. Now V equal the triple product. We write first AB, 1, 0, 2, AC, 2, 1, 1, AD, 2, 2, and 3. Okay, and we calculate it. Of course, you can calculate it using calculator, but it is easy here to calculate it without calculator. 1 multiply 3, 3 minus 2 multiply 1 equals 2, minus 0 multiply 2 multiply 3, it is 6, minus 2 multiply 1, it is 2, plus 2 multiply 2, it is 4, minus 1 multiply 2, it is 2. 1 multiply 3 minus 2, 3 minus 2, it is 1. So we have 1 minus 0 plus 4. Okay, equals 1 plus 4, it is 5. And always V equals absolute of the result, equals 5 cubic units. Next question number 28. Here we have 3x minus 1 all power 5 equals a bx plus c x squared plus d x power 3 plus e x power 4 plus f x power 5. Then a plus b plus c plus d plus d plus e plus f equals. To get this value a, to get a plus b plus c plus d plus e plus f from the right hand side, only put x equals 1. When you put x equals 1 here, instead of x you write 1. Substitute x equals 1. What you get? A plus b multiply 1 equals b. C multiply x square, it means c multiply 1 square, plus d multiply 1 power 3. 1 power 3 equals 1. So 1 multiply d equals d, and so on. And also substitute x equals 1 in left hand side. So it is equal 3 multiply 1 minus 1 all power 5, which equal 3 multiply 1 equals 3 minus 1 equals 2. So we have 2 power 5, which equal 32. And we choose letter C. Question number 29. If A equals A0, 0, 0A0, 0, 0A, then determinant of A multiply determinant of A adjoint equals. First, we calculate determinant of A. Determinant of A equals determinant A 0, 0, 0A0, 0, 0, A. This determinant in triangular form, so its result equals A multiply A multiply A equals A power 3. How you get the adjoint of A? First, we will get the cofactors matrix. Cofactors matrix. So cofactors matrix, I'll denote it by the symbol C, equals cofactors. What is the cofactors of this element? The first element here is A. Its cofactor is this minor determinant, the value of this minor determinant, which equal A multiply A minus 0 by 0. So the result will be A square. Okay. Again, with respect to second element 0, here 0. What is the cofactor of this element? It is negative. The value of the determinant consists of these 4 elements. Okay, so 0 multiply anything equals 0, and the result equals 0. And the cofactors, the cofactor of the third element in the first row, 0 multiply this minor determinant equals 0, and so on. Here we delete it. What is the cofactor of this element? It is 0. What is the cofactor of this element A? It will be A square. Here is A, and the cofactors, the determinant of cofactors will consist of these 4 elements here. So it will be A multiply A minus 0 multiply 0. A multiply A equals A square. The cofactor for this equals 0, 0, 0. The third one, what is the cofactor of A? Here. The cofactor of this element is the value of this determinant here, okay? Equals A multiply A minus 0 multiply 0. A multiply A equals A square. This is the cofactor. And the adjoint, this is the cofactors matrix of A. Don't forget. Now, the adjoint of A. Adjoint of A equals the transpose of C. transpose of C. How you make the transpose? Make the first row as a first column. So we'll get A square 0 0. Second row will be second column 0 A square and 0, and also 0 0 A square. Now we will get the determinant of the adjoint of A. Equals here we have A square 0 0 0 A square 0 0 0 A square, which equal A square multiply A square multiply A square, because this determinant in the triangular form, which equal A power 6. 2 plus 2 plus 2 equals 6. And the required is to find determinant A multiply determinant of adjoint of A adjoint, equals determinant of A, we calculate it, equals A power 3 multiply A power 6, so the result equals A power 9, and we choose letter C. Last question, question number 30. If the determinant A power 3 minus 1 A square A, B power 3 minus 1 B square B, C power 3 minus 1 C square C equals 0, where A not equal B not equal C, okay, then A, B, C equals one of these, 0 or 1 or negative 1 or 3. First step, we will divide this determinant into two determinants. So delta equals, the first determinant will be A power 3, okay, A square and A. Second row, B power 3, B square and B. C power 3, C square and C. Plus, using the properties, here it is negative 1. Notice that A power 3 plus negative 1 equals the first element here, A power 3 minus 1. Again, here we write negative 1 minus 1, okay, it is the same. C power 3 minus 1, it is C power 3 minus 1, okay. Here we have A square, B square, and C square, A, B, C. So delta equals, we can take A as a common factor from the first row, and B from second row, and C from third row. So we'll get A, B, C, okay. A power 3 divide A square. A square divide A equals A. A divide A equals 1, okay. After you taking B as a common factor here, this B, we will get B square, B, and 1. Also, with respect to C, we have C square, C, and 1. We can take negative 1 as a common factor, minus, here we have 1 A square A, 1 B square B, 1 C square and C. Okay, delta equals A, B, C. We have the first determinant, A square A1, b square b1 c square c and 1. And now I'll trying to make this determinant like this. Notice that we have the same elements, so we will change the places of the columns. First, when you interchange C1 and C2, what you get? First, you must change this sign. It will be positive. Here we have a square, b square, and c square, and 1, 1, a, b. Okay, and we will interchange the two places of C2 and C3. What you get? Okay, we have a, b, c, a square, a. It is the same determinant without any change. C square C1. Again, when you interchange these two columns, you must change this sign again, multiplying by negative. It will be negative. And here we have a square, b square, and c square. Here we have a, b, c, 1, 1, 1, and 1. Okay. Here we have the same determinant. Now we can take it as a common factor. So we rewrite this in the form ABC minus 1 multiply a square a 1 b square b 1 c square c and 1. Note that a not equal b not equal c. It is given here. A not equal b not equal c. So the value of this determinant not equal 0. The value of this determinant a square a and 1 b square b 1 c square c 1. This determinant not equal 0, but this product equals 0, right? Here from the beginning the determinant equals 0, so here we have equals 0, right? Equals 0, equals 0 in all steps, equals 0, but this determinant not equal 0. So a b c minus 1 equals 0. It means a b c equals 1, equals 1. So this result here ABC equals 1 here. So the answer is letter B. Letter B, right? And this is the end of this practice exam in algebra. Goodbye and good luck.